here it's just L prime, which is the relative length, times alpha. Alpha is just 1 over gamma, and L the proper length. So this goes at the length begins to contract as the speed of the object increases, like a spacecraft. The problem is, how is it contracting? How does it contract? What happens to the people inside a spacecraft once as you go near the speed of light, it's almost totally contracted, collapsed? And what happens to everything? And what happens when you slow down or stop? Does it magically just expand again like an accordion or something? And if you have a 12-inch, 10-foot rod of tungsten steel, and you put some cooked spaghetti next to it, 10 feet of cooked spaghetti, do they contract the same length? Is it proportional? Is it based on a percentage? Is it taking into account some other factor within the objects themselves that make them? Well, you have to explain that. You have to explain how that works, and I don't think you can do it, right? So again, I mean, I've seen experiments, even to this day, people talking about the length contraction, and they found the length contraction. It might give an appearance, right? It might give an appearance, but it's not a reality. It's not a reality. It's simply an appearance, and you can't take an appearance and put it into an equation, come up with a number, and think it has anything to do with reality. That's what I'm against. That's what I'm talking about. So Lorentz factor, everything here, right? I mean, it's almost like magic that it happens, because there's nothing there. There's nothing there to pin it to reality. I always like the cartoon I saw one time. It's like two scientists standing on a chalkboard. One looks like the older professor, the other looks sort of like the newer, younger professor, and there's a chalkboard, and there's figures writing all over it, mathematical equations, and there's a box, and in the box it says, "Then a miracle happens." And the caption is the older scientist pointing to the box saying, "I think you need to be more explicit here." Right? I think you need to be more explicit here. It doesn't work. All right, give me a second. I'll be right back with another board. All right. This is something else within the special theory, right? Mr. Einstein said that c, which is what we talked about, what is the speed of light? Is the speed of light upper bound? Einstein said yes. I say no. Right? Is c prime is the upper bound speed in the universe, right? And then he goes on to say that c squared, E, right, energy, total energy equals gamma times the mass times c squared. Well, you can't have c to the first power being the upper bound and just then throw in c squared and think everything's okay. I mean, that's simply somewhat illogical. I've asked several people about it, and nobody's given me a straight answer. Sometimes it does cancel out in certain circumstances, even I've done that. But in this case, it doesn't. If the velocity is 0, this just becomes 1 and the gamma goes away. But if v is anything, then the energy increases, right? So the c squared never goes away, and here you have c being the upper, and the energy, I say something's wrong, right? Yeah, no meaning. It has no meaning in reality, and it doesn't have really anything to do with nuclear weapons and whatnot. For those that I talked about what Einstein was talking about with flying at the speed of light and so forth like this. This is a book that I got like long time ago, probably 15 years, more than that. It's just Einstein for beginners. It's fun to read. and most of the ideas within the special theory, general theory, and others I disagree with. But if you don't have a background in Mr. Einstein's theories, or only a little science maybe, you don't even need a lot of math. Like I said, it's a fun book to read, and it gives you an overview of what Mr. Einstein was talking about. So you can use that too. Now, here I broke up the Newtonian view and the Einsteinian view, right? So this starts to get into the general theory, right? It's general theory of relativity. So Newton's view we kind of know. You know, the sun over here, Jupiter there. There's a gravitational tether, right? There's a gravitational field, and they're in the field, and the sun, you know, through Newton's third law of motion, right, exerts a force, an attractive force on Jupiter. Jupiter exerts an attractive force on the sun, right? So that's what holds it together. And then the planets in motion stay within that orbit, always having that tether of gravity with it. Right? Einsteinian view is not. That Einsteinian view doesn't have that gravitational tether. I mean, John Wheeler said it, that space-time tells matter how to move, and matter tells space-time how to curve, right? So if you have here, you're looking at a side view of our, you know, basic solar system, and here's the sun. And if you look at it, according to Einstein, you have to have all these gravity wells, right? You have to have all these gravity wells for the different planets, because that's how they stay within their orbits, or that's how they stay within place. I think it's a bad idea, right? I think the general theory, and it's just a bad idea that it does this. I mean, you have to find those gravity wells. But with planets, in other words, Einstein's general theory can't be used to describe the motions of the planets within our solar system around the sun. It can't be used for that. If it does anything, it goes back to Newton's gravitational view. But if you do that, then why have the general theory? Just use Newton's view. At least we know it works. So what you would have to have for the planets is something like a gravity trough, right? Instead of just a well, you know, at the bottom or whatever, depending on how you're looking at it, you'd have to have a trough that goes all around the solar system to keep that planet in its orbit. There's nothing else to keep it there if you just have one gravity well. I sort of liken it to one of those large spherical buoys that you see sometimes, right? That represents like a planet. It's in the water. It displaces a little bit, right? Because it's basically hollow. It displaces a little bit, and the only reason it stays in place is because there's some anchor or something that keeps it there. If it starts to move, it stays on that rope, that tether. If you cut that rope and let it go, it's just going to go flying off somewhere. The waves, the wind, whatever, it's just going to go flying off. And it's not going to stay unless it has some kind of tether. And I don't think you're ever going to find a gravity trough that would hold the planets in place. So, yeah, so okay, let me look for a second here. Oh, let me say one thing about sort of going backwards a little bit. Math won't help, what I'm talking about before. Math won't help in answering these questions about the Lorentz-Fitzgerald contraction, twin paradox, time dilation, the upper bound speed of the universe, upper bound speed within the universe, the Lorentz factor and whatnot, right? Math's not going to help for these questions, for it's completely impotent. Different numbers will give you different solutions, but it will not aid you in your understanding of the concept. Here, one has to use logic and words, scientific principles to describe and explain how the physical system works. And that's something that's missing. I mean, you have to explain how it works, and no one has ever done that. Why? Because it doesn't work. Everybody just keeps it like it's something holy, and it's not. So the Lorentz factor, time dilation, Lorentz-Fitzgerald contraction have absolutely nothing to do with reality. So, yeah, so here over this, so, you have to have a gravity well to just stay in place. You'd have to have a gravity trough so that it would go around the sun in its orbit. But you're not going to find that, right? It doesn't exist, and you're not going to find that. We know that the Milky Way galaxy and the Andromeda galaxy are moving towards each other, right? If you had Einstein's idea, right, you would need to find, again, either another large gravity well or some kind of gravity trough that those two are sort of sliding down into, because that's basically how people think it works. I can guarantee you're not going to find that. It doesn't happen like that. So I think there's just a lot of ideas nobody can explain. Everybody uses the math, but what comes down looking at particulars like, well, how does that happen and how does that happen? There aren't any ideas. I haven't heard any ideas coming from any of the scientists. They just pretend that it works and doesn't bother with getting into the bits and pieces of it. So that is, all right, so that's getting into the general theory a little bit. Yeah, and I think a lot of frame dragging. I've read the papers, but I have to say I found them extremely inconclusive. It reminds me of Michelson and Morley looking for luminiferous ether. And the other problem is confirmation bias, right? This is the idea that you're so want to find that your idea is correct or Einstein's idea is correct, that you either overtly or covertly you put you do something to the data, or you set up the model, whatever you're doing to get the answer you want, right? Or you could say basically like people tend to find what they want to see. And I think that goes for a lot of Einstein's theories. Okay. Yeah, the other thing is, I think I told you that about time. Time is a concept and can't be embedded into space, to come up with space-time. It doesn't work. The time is up for space-time. That's one of my videos. And breaking the light barrier, yeah, I said that. Okay. Like I said, I need my cheat notes. All right, so that's good for that one. Let me go get another one.